Okay, let's have a look at another similar triangles question. This one, it was off a sample paper in 2014, question 9. 3 paths, AE, BE, and CD have been constructed to provide access to a lake from a road AC as shown in the diagram. The lengths of the paths from the road to the lake are as follows. From A to E, it's 120 meters. From B to E, it's 80 meters. From C to D, it's 200 meters. Explain how these measurements can be used to find the length of ED. Okay, so the trick to this one is to be able to spot the two triangles, okay? So you have one triangle here, and then you have the other triangle here, okay? So don't make the mistake of spotting the triangle and then spotting this four-sided shape, this quadrilateral, okay? It's triangles. So what makes two triangles similar then? Why am I calling these similar triangles? Well, if you remember from the theory we did last week, there was a few different conditions that made triangles similar. One of them was their angles are the same, okay? So if I draw out the two triangles, okay, sometimes it can be easier to see. So ABE is that one, and then draw the bigger one, ACD. ABE, ACD, okay? Now, can you see that angle B is definitely equal to angle C? Why? They're both 90 degrees, okay? Now, the other one to spot is this angle A, okay? So when they have a small triangle inside a big triangle, you always end up having a common angle. So this angle A is the same angle A that's here, okay? So if you remember from last week, I just used dots to show which triangle or which angles are the same. So the one dot at A means those two angles are the same. And then I'm putting a dot at B or 2 dots at B and 2 dots at C because they're the same. And then how can I just say then that E is equal to D? Well, angles in a triangle add up to 180. So if that's equal to that one, and the right angle is equal to the right angle, then whatever degrees is left over in this small triangle for E is the same amount of degrees that's left over in the big triangle at D. Okay, so how do we answer this wordy question? Explain how these measurements can be used to find ED. Okay, so E is in the middle of this triangle here. So if I put E in there, okay, so what you're going to do, all you can work out is the length of AD, okay, because that's what's on the big triangle. And that's what made this question quite hard to spot, because ED kind of lends itself to you looking at the four-sided shape instead of the triangle. But all you can find is the length of AD. You know what AE is, because it told you here it's 120. So if you subtract one from the other, then aren't you left with ED? Okay, so to answer this one, I would say the triangles AEB and ACD are similar, as shown. Therefore, okay, now I'm going to use the theorem. If you remember the theorem, we put corresponding sides over corresponding sides. So, and it doesn't matter whether it's the small or the big on the top. I'm going to say AD, the big one on the top, the length of AD, the length of AD, okay, so that's that side. So what side does it correspond to in the small triangle? Well, AE is equal to, okay, CD over what's the side in the small triangle? BE. Okay, I could also have in there the bottoms. Okay, so I could have AC, the length of AC over the length of AB, okay? It's just, I have no information about AC or AB, so that's why it's not really much use to me. But it is true, they're all equal to each other, okay? So we're going to use the above theorem or formula or ratio, whatever you want to call it, to find ED. Why? Okay, because AD minus AE equals ED. Okay, or something to that effect. You can write it down in English, you can write it down in maths language, whichever you feel more comfortable doing. So let's find ED then. That was the second part of this question. So find the length of ED, okay? So I'm going to use AD over AE is equal to CD over BE, okay? And from here, you fill in whatever numbers you have. So do I have AD? No, that's what I want to find. So leave him as AD over AE is 120, which is equal to CD 200 over BE 80. Okay, if you remember, we cross multiply so that you have 80 times AD is equal to 120 times 200. Okay, remember from last week, you follow the cross. Okay, and you end up with no fractions. That's why we do cross multiplication. And I'm just looking for my calculator. Let me just grab it. Okay, so 120 by 200 is a big number. So I have 80 times AD is equal to 24123. Divide by the number in front of what you want, just like you would with any other algebra. And I get AD is equal to, so I have to divide that by 80, 300. Okay, not quite yet done, so that should be the length of AD. This 2 lines down the side is maths language for length of. So I just have to do the subtraction then. So ED is equal to 300. So that whole thing is 300. So I'm going to subtract off it AE, which is 120. So I'm getting ED to be equal to 180 meters. Okay, so that is similar triangles.